Hi folks, welcome back to Math with Captain Rod. Actually Physics with Captain Rod. I'm making this video here to help you out in number 51 on chapter 22 in your OER college physics text. So the problem is about a pair of wires. You know, it says something about a pair of jumper cables, and hopefully everybody's worked with a pair of jumper cables before. You know, you've got two separate wires surrounded by some insulating material. So here I've drawn this kind of pair of wires, maybe exaggerated this distance just to for clarity in the picture. Although it's not said how long they are, they have to have some sort of length. It says something about the distance between the wires. It says something about a current. Now these are effectively one wire because up here somewhere, you've got like the battery plus hooked to one, minus hooked to the other. So the current's like so in this picture, and they're the same value. Now, it also says something about force per unit length. So what that is it's F over L. This is some number that I think is given in that problem. Now, the analysis of this. I'm going to pick one of these wires to talk about. Let's talk about this one. So the field lines around it are circular, and you tell which way by right-hand rule. I'm only going to draw the one field line, but it's important to realize over here where this second wire is, the field lines, the magnetic field vectors produced by this current are this way in the minus K direction everywhere along this wire. Got a picture like where this circle intersects the plane. Now, next, the field strength of those wires is mu sub O over 2 pi I over whatever this distance is, which I've got labeled as D. So here's an expression for the magnetic field vectors along the wire on the right. But again, the important thing to realize is this I is this one. These are the field vectors produced by this current. All right, next you have this current now that's going to interact with these magnetic field vectors. And the magnetic force on a wire is IL cross B. All right, I is this current, L, whatever the length of the wire is, times B. I'm going to just put this here, but that's what we're going to use this for, times the sine of the angle between the I and the B. Now this current is in the what I would generally call the minus J direction in a standard X, Y, Z coordinate system. The magnetic field vectors are in the minus K, so I'll let you figure out what the angle is between them and what the sine of that angle is. Next, let's talk direction here. So that force, by the way, you take your left hand parallel to this, rotate, you can sweep towards those magnetic field vectors. That force is going to be to the right. Make sure that that's correct here. These are this way. Yep. And that force is going to equal, by the time you put this stuff together, you'll get some sort of expression. Now when you get that expression, put this length over on the left so that it reads F over L equals some sort of number. Or, well, equals some number which you're given in the problem. And that's going to equal what we have here, IB times sine of theta. Oops. So that's going to allow you to calculate one of those unknowns. That should be enough to get that problem done. All right, hope you enjoyed the video. Have a great day.